Now this theorem says if AD bisects the vertical angle A of triangle ABC meeting the base BC at D, then the product of AB and AC will be equal to BD into DC plus AD square. So this is talking about angular bisector AD. Let us say I've got this triangle A, B, C, and bisector of this angle A is AD, right? So this is angular bisector. What it means is that this angle is equal to this angle here. Now the product of these two segments, these two line segments AB and AC is equal to product of BD and DC plus square of this angular bisector AD square, right? How do we think about it is, let us draw a circle passing through A, B and C. These are three known collinear points, hence there will be a unique circle passing through A, B and C. Okay, once you draw this circle, extend this AD to meet this circle at this point. Let us name this point as M. Okay, if I join this point M with this C, okay, now look at these two triangles, triangle ABD and triangle AMC. Okay, I want you to focus your attention on these two triangles. Why? Because in triangle ABD, this angle is equal to this angle in triangle AMC, right? Both of these are alpha because this AD is angular bisector, right? And what can you say about this angle and this angle? This angle here. If this is beta, what will be this angle? This angle will also be beta. Why? Because if you look at this arc AC subtends these two angles in same segment of the circle, right? Hence these two angles are equal. So this triangle ABD is equiangular to this triangle AMC, right? So these two triangles are similar to each other, and if these are similar to each other, the ratios of their corresponding sides will be equal. That is, AB divided by AM will be equal to AD divided by AC. AD divided by AC. Now if I take a cross product, that is AB into AC, it will be equal to AD into AM, right? It will be equal to AD into AM. So AB into AC is required, AD is required in the final result. What is AM? AM is AD plus DM. It is AD plus DM. So let me write AM as AD in AD plus DM. Now if I take the product, it will be AD squared plus AD into DM, right? So AB into AC is equal to AD squared plus AD into DM, right? And what is product of these two segments, AD and DM? It will be equal to product of BD and DC, because we have just studied about secant property of the circles, right? That if there are two chords, let us say, intersecting like this, then the product of this segment and this segment will be equal to product of these two segments. So AD into DM is equal to BD into DC. So let me replace this AD into DM with BD into DC, right? So AB into AC, that is product of these two sides, is equal to product of these two segments and AD square. Okay, so this is how we will think about it. And this theorem can be used in various ways. If let us say the lengths of these sides are given, AB, AC and BC, and you are supposed to find the length of this angular bisector, you can use this theorem to find the length of angular bisector. If some students are confused, how will we find BD and DC then? We can easily find BD and DC. If this is angular bisector, then BD and DC will be in the same ratio as AB and AC, right? This is angular bisector theorem, which we have already studied. Okay.